In today's lecture, we will cover the derivation of green function by using covariant approach. It covers 10 to 11 marks in the question paper, and it is very easy to derive by using the covariant approach. Derivation of green function by using covariant approach. So we have given the solution of potential that is box operator alpha xt, and it is equals to 4 pi by c and j alpha xt, that will be operate on whole by using covariant approach. On the whole by covariant approach. Now it is only feasible in Lorentz gas, so it is only feasible in Lorentz gas. Now we define the box operator that will be used in the further. So box operator, that is equal to del mu and del mu, and it is also equals to 1 by c square del by del t square and minus of del, that is equals to gradient square, or we can write it as gradient square. Now we have the solution answers. That is equals to a alpha x lambda is equals to 4 pi by c and del 4 x dot j x lambda, and we will also define here as the four-dimensional covariant green function, that is d of x lambda and x dash lambda. So let's say this is the equation number 1. Operate box operator on this four-dimensional covariant green function. So d of x lambda x dash lambda is equals to d4 x lambda minus of x dash lambda. Let's say this is equation number 2. Now where this term, where d of x lambda x dash lambda is our four-dimensional covariant green function, and let's say assuming this as translational symmetry, assuming the translational symmetry. So we know that this four-dimensional covariant function is also, we can write as d of, we know d of x lambda x dash lambda is equals to d of r lambda, and r lambda is equals to x lambda minus of x dash lambda. That will equation number 3. Now by using the non-covariant green function, we can prove the derivation of green function by using covariant function. Means that we use the solution of equation of non-covariant approach of green function to derive the green function. So we should have the solution of green function of non-covariant approach. So the solution of green function, that will be R in R space. So solution of green function by using non-covariant approach, that will equal to 1 by 2 pi by 4, and that will equal to 4 R. It will be in K space. So dk and d of K alpha R alpha. Let's say this is equation number 4, and we can also write this in the K space. Now changing R to K space, changing R space to K space of D. So we can write D of K lambda is equals to D4 R, and D of R lambda plus of I K alpha and R alpha. We write this by using the inverse of Fourier transform in the inverse Fourier transform. So in Fourier transform we can write it as, so this is the Fourier transform. Now let's say this is our 4, this is our equation number 5. Now in the other hand, we have is equals to 1 by 2 pi 4. So let's say this is equation number 6. So we have del 4 R lambda, as well as we have this term, and also D of R lambda. So from this, from equation number 6, and this is from equation number 5, right? Sorry, this is from equation number 4. So plugging the value of equation 6 and equation 4 in equation number 2. In equation number 2, so we have this value and this value. This is from equation number 6, and this is from equation number 4. So plug this. We write this first, R lambda, so 1 by 2 by 4, and D of 4k, and D of 4k, D k space into I k alpha R alpha, and this term 4 D4k Now proceed further this. We use this box operator to this function. So and we can clearly see that this term is also equals to this term, so this got cancelled. Now d4k d of k lambda and this minus of k alpha r alpha is equals to d4k e of k alpha and r alpha. Now we know that we operate this box operator here, then this will become eta of nu mu, and this got differentiated with d of k mu and d of k nu e of I k alpha and r alpha. And also if mu is equals to nu, then it will become neta of nu mu and minus of I k mu into minus of I k nu, and this will become this will become simply k mu and k mu when this mu is equals to nu, k mu and k mu in the subscript, and this is in superscript. So put this value here. Now d4k of d of k space of lambda and this eta of mu nu d of dk mu and d of dk nu e of minus I k r alpha and k alpha and r alpha. So d4k and e of minus of I k alpha and r alpha. d4k, this will become k of mu k mu and e of I k alpha and r alpha is equals to d4k e of minus I k alpha r alpha, and this also got cancelled here and this also, and we will get this term as minus of I k mu this, so it will become minus of I, because let's see, check here, it will become positive and iota square k mu and k mu, so iota square is become minus of 1, so it will become k mu and k mu, right? So a minus term got outside. D of k lambda is equals to 1 upon this will goes another side and it is in denominator, so k mu of k mu, and finally d of k lambda is equals to minus of 1 k mu and k mu. Let's say this is our equation number 6 and this is our equation number 7. Now put this value in equation number, put the value of d of k lambda in our equation number 4 here, so it will become d of r lambda. D of r lambda is equals to 1 by 2 pi 4 d4k d of k lambda into, now put the value here, equals to 1 by 2 pi 4 d4k. What was the value of dk lambda? That was minus of 1 upon k mu and k mu E times k r. Now also here when we break this 4 vector in, then it will become k, and this will become k r alpha is equals to k naught r naught plus k vector. This is in a space and this is in vector, sorry, yeah, this will dissociate like this. So put this value here, and what we will get after putting this, we will get 2 pi 4 d4 k. Let took this negative sign outside, and this term d of 3k into dk naught, and this will become this e of in positive I k vector and r vector, and e times minus of I k naught r naught upon, and this will break into k mu, and k mu is equals to k naught square minus of k square. So put here k square. Now write in clear form, minus of 1 upon 4 pi 2 pi, sorry, not 4 pi, 2 pi to the power 4 3k e of I k vector and r vector, and this will become ik. What will be ik? Where I of k is equals to this term dk naught e of minus I k0 to k0 and r0 upon k naught square minus k square. So this is our equation number, let's say this is our equation number 8, and this is our equation number 9. So now evaluate ik to get here, to get the value of ik here. Now evaluate ik. So for evaluating ik, this is our simple pole at k is k not equal to k. So our integrand of ik, the integrand of ik here is simple pole at k not equal to plus minus k, and let's say the value of k naught is complex valued, so it is convenient to assume the value of k naught in complex, and carry out the integration over a chosen continuous, and carry out the integration carry out the integration over a chosen continuous. Now we have I of k is also equals to I of continuous k, and this will also equal to continuous ik. And what will this, what was that ik? That is this. Now let take k naught in the chosen contour, in the chosen contour. So this is our chosen contour. So k naught is equals to in real part and also in imaginary part. So and this will also dissociate in the one of the following value of in the lower half plane and in upper half plane. So this is our equation number 9, and this is our equation number 10, and this is our equation number 11. So let's break this in our chosen contours. Now minus of k to k, and this is our in R contours, and this is an R A. So this is contours of R of CR, and this is contours of R of CA, right? This is the imaginary k naught. This is the imaginary k naught. Sorry, k naught. Now we have e to the power minus of I k naught and r naught, and we have also value of k naught here. From here k naught, put this value k naught from equation number 11 to here, then what we will get? E of minus I k naught, what was k naught? R of k naught, and plus imaginary k naught, and here this r naught. Now this will become minus of iota, this r naught and r k naught, and this will become minus of I square, I k naught, and the multiplication of this I r naught, and further it will become I of r naught r k naught, and this will become negative, and iota square is also give negative, then it will become positive. I k naught r naught. Now write it as I r naught r k naught r naught, sorry, r naught imaginary k naught, and this is our oscillatory factor. And this is our growth or decay factors. Yes, this is our decay factor and the growth factor. Now if our imaginary k naught is diverges in here, it is equals to greater than or equal to 0, then it diverges in the this upper half plane or in lower half plane, then it diverges. In upper half plane or in lower half plane. So take the case for upper half or the lower half. So case 1 for r is greater than 0, then here it is only feasible contours for this condition when r is greater than 0. So only feasible in the contours of r and cr and it will be in, and this is in the lower half plane. It is in lower half plane. So as I of k is equals to, we will have this, I contours, this is contours k plus I contours cr or r, I contours k, and this will become 0. Why? Because in the limit of k naught is equals to infinity or I k naught is equals to minus of infinity, then this will become 0 in the limit k naught tends to infinity and I k naught is equals to minus of infinity, it got 0. So we have I k naught is equals to this term or this term, this is contours, and this term I k. So we have this value from the equation number 9 put here. Then what we will get, and also we introduce a step function here in the multiplication form of the ik. So it will become ik is equals to, this is our step function r naught and contours r ik. We will put value here after some time, so take it as it is. We say this is our equation number, sorry, I forgot to write the equation. This is our equation number 12, 11, 12, and this is our equation number 13. And also we know the I of contours r is equals to I of contours minus of I contours a. So case 2, let's say this is our step function, and what was the step function got 1 when this r naught is greater than 0, and here we have r naught is greater than 0. So let's say y, when this got 1 when y is greater than 0 and otherwise 0. Now case 2, remember this equation we will use further. Now case 2, at r naught is greater than 0, sorry, less than 0, so only feasible in the chosen contours of CA, only feasible in contours R of CA. So it is in upper half plane. R was in lower half plane and it is in upper half plane. It is in upper half plane. Now we have IK is equals to I contours A, that was in R and it is in A. K plus I contours A of K, also this got 0. Same, in the limit K naught is equals to infinity, tends to infinity, and K naught is equals to minus infinity. In the limit K naught infinity and I of K naught is equals to minus infinity, then this will become I of K is equals to this I contours A K, and this is also equal to contours IK, and here this is equals to minus of I contours R. So IK will become, and this is also come with a step function. This is our step function. This is our step function. So IK, now step function of IK, and if we consider here R contours R, then it will contours R minus with A, so this will become minus of contours R, A not R, this will become minus sign. So here IK is equal to minus of R, and with the same, the condition is same. So here contours IK with contours R. Also remember this equation. This is our equation number 14. Now fourteen, 13, 14. Now put the value of IK from here and from here in equation number, this value in equation number here. We can also put here in equation number 8. Then what we will get? We will get the value of dr lambda. Now put the value of IK. So what equation number 8 become? R d of r lambda. D of r lambda is equals to 2 pi 4. Wait a moment. Now 4 in K, sorry, it is in 3, the 3K E of IK and IK. Now we will put the value of IK here. then it will become 2 of 4, and ik was this, d of 3 k I of k alpha r alpha, and this value what was the value of ik? Value of ik with this step function. In first case, in r, we take here r in r contours, so with step function as r, and this I R K. This is our equation number 15. Now in A contours in the upper half plane, this was in lower half plane. Now for upper half plane, d of A r lambda 2 pi 4 for A. We have for A sorry, that was for r is less than 0, r is less than 0, for r is greater than 0. So step function r and 2 this I of r k with minus sign. In A with minus sign, we have this minus sign, right? This take out the minus sign here. Now it will become our equation number 16, I guess. Yeah, 16. Now according to this equation, we have dr or dA. Then this is only feasible condition. Why? Because it is in upper half plane and it satisfy the condition of this step function, and we use this value. I will show this value is here in equation number in equation number 1. So in equation number 9, now this value is r, and it is in, first of all we have to find the value of I of contours r, because here we can see here also contours r is available, and also here contours r is available. Then we have to find the value of this contours r, then put here, then after the value of dA or dr put in equation number 1. So first of all we have to find the value of this. So from equation number this we can find as I of, for finding the value of this I k contours r. Now I of contours r of k is equals to, and we have this, we can also know that, we know that this value is also equals to ik, and ik is equals to this. So we can put the value of ik here in contours of r. The ik was dk naught e raised to power I k naught and r naught, right? And we have also k naught square minus of k square. Now it will give the residue, the sum of the residue, so it will become I contains r and k, it will give minus of 2 iota and residue of k naught minus of k. First of all, k naught of minus of k, and wait a moment, k naught minus of k, then it will become k. So yes, k naught is equals to k, k naught is equals to k, and sum of residue, so residue k naught is equals to minus of k, right? Then it will become minus of k and it will become plus of k. So minus of 2 pi I, then this become k naught minus k, and this term k naught r naught, k naught square minus k square plus residue, sorry, this term k naught, and it will become plus of k. If take it in left hand side, then it will become plus k and e times this k naught r naught upon same k naught square minus of k square. Minus of 2 pi I. So we break this in a square minus b square formula. So k naught minus k, and this will become minus of I, k naught r naught, and this will become k naught minus of k into k naught plus of k, and this got cancelled, and here also k naught plus of k and e k naught r naught, k naught plus of k and k naught minus of k, this also got cancelled. Now minus of 2 pi I iota minus I k naught r naught upon k, and this is at k equal to k naught, and this is equals to k equal to minus of k. So this is at k naught equal to k, and this is at k equal to minus of k, right? So k naught plus k at k naught equal to k plus, don't get confused, this is for this equation, and minus I k naught r naught, k naught minus k for k equal to minus of k, and this is for this equation. And put the value of k naught equal to k here and k equal to minus k here, k naught equal to minus k here, then what we will get? Minus of 2 pi I minus of 2 pi I upon k naught minus k. First we write, then we will put k naught equal to k plus I k naught r naught k naught plus k at k naught equal to minus k. Now put here also k naught equal to k, so k r naught and k naught equal to k minus k, k minus k. It should be in plus, I think. K naught plus k, yeah, this is in plus here. K naught plus k, k naught plus k, and this will be in minus k naught minus k. So k naught plus k, put the value of k naught equal to k, then it will become 2k. And here also k naught equal to minus k, k naught equal to minus k, then minus iota into k naught equal to minus of k r naught, then it will become plus, positive, it will become plus. So k naught equal to minus k, it will become minus of 2k. So minus 2 pi iota e times minus I k r naught upon 2k plus minus of 2k e raised to power plus of I k r naught, right? Now take the LCM of this and take out minus of 2 pi I and 2k, right? This minus of I k r naught and minus of e I k r naught. Now 2 got cancelled, minus of pi I by k, and this e of minus I k r naught minus e times e raised I k r naught. And we know the we know the formula of iota raised to power I theta minus iota I theta is equals to minus 2I sin theta. So put the value of here, minus pi I k minus of 2 I kr sin kr naught. So it will become plus, first it will become plus, minus get plus, and this iota square get give minus sign. So minus of pi by k, minus of pi by k, right? Iota square, wait a moment, this will become 2k, and 2k minus of pi I by k, minus pi I by k will become 2, yeah, 2 get outside, that was missing, I was missing that 2. So 2 pi k sin k r naught. To get equation number 16, and I call it as equation number 17. Now put the value of this, is equals to minus of 2 pi by k sin k r naught the value of equation number 18 in equation number 16, then what we will get? Put the value of equation number 18 in equation 16. Let me see the equation number 16. Yeah, this value. So d of r lambda is equals to minus of 2 pi to 4 d3k and this value here. Sorry, we write this in equation number 15. In equation number 15 first in r, then after we will write in a in equation 16 with this negative sign. So r, now the value of this minus of 2 pi upon k sine k r naught, and then it will become d of r lambda 2 pi, take it minus outside 2 pi, then it will become 2 pi q k, so it will become 2 pi q, and take this outside k d3k I k alpha r alpha, outside 2 got cancelled and also pi got cancelled. Now k sine k alpha. Now proceed this equation. So d of r lambda is equals to minus of 1 by 2 pi, minus of 1 by 2 pi 3, write it as a step function r naught d3k I k alpha r alpha and k sine, what was sine k r naught, right? So dk k square. After writing I will tell how this happened. K e of I k alpha r alpha sine theta d theta d phi. So I write here this d3k as dk and k square, and this integration term give another sine square. So sine square, and after the integrating this in phi term, theta term and k term, then it will become I kr cos theta. So write it as d of r lambda as this minus step function r naught by 2 pi 3. So, and we have also k in denominator, so this k and this k got cancelled and we get 1k in numerator side. So dk k and k, we have sine kr naught. That was from the equation, and this get sine theta. Sine theta d theta. So sine k r naught from 0 to infinity and d phi 0 to 2 pi get d phi, and also 0 to pi sine theta, this term sine theta d theta, and this I kr cos theta. And also this also we can write this as 0 to infinity, 0 to 2 pi, 0 to pi, and combining this dk k sine kr and d phi sine theta d theta e of I kr cos theta, and the value d phi 0 to 2 pi give pi 2 pi, sorry, give 2 pi, then it will become minus of phi 2 pi cube, and this d phi term give 2 pi. Now we left with 0 to pi and 0 to infinity, 0 to infinity with dk k sine of k r naught, and 0 to pi, this term will give 0 to pi sine theta d theta, right, d theta sine theta d theta e of I kr cos theta. Now we have to solve this term. So 0 to pi, then it will become 0 to pi. At 0 it will become minus 1 to plus 1, and let cos t equal to cos theta and dt is equals to minus of sine theta d theta dt, then it will become dt, and this will become t I k r t. So minus of dt is equals to sine theta d theta, sorry, theta sine theta, sorry, dt. So we digest this dt, minus of dt, by taking as positive to negative. So dt e of I k r t of dt, so it will give us as I k r upon I k r. Sorry, first it was in plus 1 to minus 1, then after digesting the minus of dt, then it will become minus 1 to plus 1. So it look like as minus 1 to plus 1 e of I k r t dt. Minus to plus, so minus 1 to plus 1. Now after putting the value of t here, then it will give I k r upon I k r minus, now put the value of lower, minus of I k r upon I k r. Now took this denominator side outside, I k r, then we will left with I k r minus of I k r raise. So we have also the formula of this I k r, means that e of I theta minus e of minus I theta, that is equals to 2I sin theta. So put the value of this 2I sin theta here and then here. Let's say this is our equation number 50. 18, and this is our equation 19, and put the value of this here, then what we will get? 2I sin theta. Let's see. dr lambda is equals to 2 pi cube 2 pi cube 2 pi 0 to infinity, and dk k sine of k r naught, and this will become 2I sin theta, means 2I k r. 2I theta is equals to k r. Here theta is equals to k r, and 2I k r, 2I sin k r, sin k r upon I k r upon I k r. So we can take this 2 outside and sin k r, and I got cancelled k r. We can cancel this k to k, and r will become, take outside r, Sine kr. So sine kr 2 pi. Now d of r lambda is equals to sine theta is equals to sine kr. We can take it as sine kr minus of step function, right? We can use identity here as r and dk upon r, so it will become 2 pi r. We can take r outside, so r also outside, so it will become, first of all, 2 pi, this got cancelled, 2 pi square into r. Now dk sine of k r naught into 2 I got cancelled and k got cancelled, r outside, 2 outside, so sine of kr. I can clearly see that it look like sine a into sine b, right? So what was the value, formula for sine a? I think sine a into sine b is equals to 1 by 2 cos a minus b, a minus b minus of cos a plus b a plus b, right? So put here d of r is equals to minus of step function r naught upon 2 pi square r 0 to infinity dk 1 by 2 of cos a minus b, so k, took k outside, a minus b means k took outside, r naught minus r, right? And minus of this cos of k, again k, r naught plus r. We can again take this half outside, d of r lambda is equals to minus of half, so 4 2 pi square r into 1 by 2, and left with this cos of k r naught minus r minus of cos k r naught plus r, and with this dk. So this will become delta of r naught minus r and minus of delta r naught minus r naught plus r, so d of r, and this d is for dr. And this will give with the pi term, so pi delta, this term become delta of r, not this minus r, and minus of delta, not cos, it is in delta, so r naught plus r. Now d of r with minus sign, step function r naught pi got cancelled and 2 become 4. So r pi 4 pi square got cancelled and it will become 4 pi r 4 pi r. And here we left with this 2. We forgot the putting the value of this 2 here, so 2 and also 2 and this half. Now r naught minus r minus of del r naught plus r. So this 2 got this cancelled here. Now dr of r and this get minus of step function and r naught by 4 pi r. This del r naught minus r and minus of del r naught plus r, and this minus sign, we proceed this by this minus sign. Let me show you this. We have the value of this dr is already in minus sign, and we find the value of this ik. Look here clearly, this ik has value with this minus sign in a, and this is already in minus sign. So in equation number 15 it come with minus sign because this dr is in minus sign, and this r on contours r it is in plus sign. So here plus and here minus come with this minus sign, right? And here this dr lambda value is in minus, and also here for a this it is in minus sign, and we have also minus sign from here, so it get plus. And we are proceeding for this now, so it is in minus sign, so take with the minus sign dr, this minus sign, right? Here also, but we were proceeding with plus sign. We have to proceed with this minus sign. So if we proceed with minus sign, then this minus and this minus got plus, right? Plus here. So we have only put the plus sign here, nothing got changed, but only this negative sign got changed here. Proceed with sign carefully. So hence we get the value of dr r lambda in r contours as step function r 4 pi r delta r naught minus r minus of delta r naught plus r. This is our equation number 20. Now for dA r lambda. So similarly we take as for dA this value r plus r, for only here r minus r term is survived, and for dA only r plus r term is survived. So take it as with negative sign. Here we have only rm term is survived, r plus r term. So this negative, no, not negative, it is in step function, and this come with also step function, right? So negative of step function minus of r naught by 4 pi r and del of r plus r, right? Del of r naught plus r minus of del r naught plus r, right? Equation number 21. Now in r case, in r only r minus r term is survived, and in A only r plus r term is survived. So our equation become step function r naught by 4 pi r and delta r naught minus r. So this is our final equation for this dr, only for dr, and in dA r lambda, this is with negative sign, step function r naught upon 4 pi r. So here only r plus r term is survived with this negative sign. This got cancelled. So negative of del r naught plus r, then this negative and this negative become positive. Step function r naught upon 4 pi r del r naught plus r. This is our required dA term in r space. dA r lambda. Let's say this equation number 20, and this is our equation number 21, and this is our equation number 22. Now we are just about to reach our final required equation. So as the delta function contribute for r naught equal to plus minus r. As we can clearly see that we have two cases for r naught is less than r, and for r naught is greater than, sorry, r naught is less than 0, r naught is greater than 0. So as the delta function, as the delta function for r naught is equals to plus minus r, the two cases, what was that two cases? For r naught is greater than or less than 0, on that we get this. For less than 0, for greater than 0, for less than 0, this is our required equation for, so right here, for r naught is greater than 0, we get dr r lambda, and for r naught is less than 0, we get dA r lambda respectively. So this is our retarded green function, and this is our advanced green function. This here dr r lambda is our retarded green function, and dA is our advanced green function. Now explicitly this is our dr. Let's say this r as r naught. Here r naught is our r minus, sorry, we can write it, but for our convenient we can write t minus t naught, and r as r by c. So what this equation 21, sorry, this is our equation number 21. Then after writing this here, then after our equation number 21 will become, with the step function, r naught upon 4 pi r delta r naught, r naught, for this, not for this, for this r naught is t minus t dash minus of r, that is r by c. Let's see, this is our equation number 23, and similarly put r naught value here and r value here, then our equation number 22 will become dA r lambda is equals to step function r naught by 4 pi r and delta r naught, that is t minus t naught, and plus r by c. So this is our equation number 24. Now we consider the delta function. Now we consider the delta function, and we have delta, the formula for delta r naught is equals to r naught square minus of r square equal to r lambda. Now we have earlierly r lambda is equals to x lambda minus x dash lambda, same as r naught square minus r square as it is. So we can also write it as r lambda into superscript r lambda. So, and the following delta function identity follow as delta function identity. Use the this follow the delta function identity and use the delta function identity as delta function identity. Delta f of x, the delta function identity was delta x minus xn, and del f by del x as x equal to xn. So put the value of this xn as r lambda here, r naught or this r lambda square. We can also put this or this. So del f of r naught that is equals to r naught plus r and minus r. It will become the summation of this, right? Summation of this. We have two terms now here as r minus r and r plus r. So summation of this. So we will become r naught minus of r upon delta of f upon this r naught, delta r naught for r equal to r naught equal to r, and this summation. So plus delta of r naught plus of r and del of this again del of r naught, and it is for r naught equal to minus of r, right? Now differentiate with this. After differentiation we will get the 2r naught, and this f r naught is r lambda square. So delta of f r naught square, sorry, r lambda square, no? R lambda square equal to by 2r delta of r naught minus r plus delta of r naught plus r, and we have the value of this delta r naught. We can put the value of delta r lambda square here or here. So it will become d of r lambda is equals to step function and r naught upon 4 pi r with this delta r naught. Then delta r naught become delta r lambda. this with multiplication of this 2r and minus delta r naught plus r, this is equals to delta r naught minus r 4 pi r. Put the value of this delta r naught minus r, this delta r naught minus r in 21, equation number 21. So r delta r naught, sorry, step function r naught 4 pi r delta r naught minus r, delta r naught minus r 2r minus of delta r naught minus r, then it will become delta r naught square, and this will become 0 at r equal to r naught. So it got cancelled, I think, because we here only survive r minus r naught term, right? So this 2r and 2r with cancel 2r, only 2 pi, it remain with 2 pi only, and step function r naught and delta this, so 2r got cancelled with 2, r with r, and delta of this term r plus r and this term, so r plus r become delta of r lambda square, right? And in case of a, similarly d of a r lambda with step function pi r, so it we can say this is our equation number 25 and this is our equation number 26. So for dr r lambda or dA r lambda are non-zero only when dr lambda or d lambda in subscript and r lambda in superscript is equals to 0, or we can say that it is for light cone condition. So take it as condition here for dr r lambda and dA r lambda are non-zero only when the r lambda square is equals to r subscript lambda, r superscript lambda is equals to 0 and r0 square is equals to r square. Let's say this is our equation number 27. Now this is our light cone condition. We have to take the which is our light cone condition. So that is our r equal to minus of r, and this is our r naught is equals to r and we have also r naught is equals to t minus t naught equals to r by c, and t minus, sorry, this is minus r, so minus r by c, and t equal to minus t naught r by c, and this is our r naught and r. And this is our light cone condition, and here world line. This is our world line. So the causality demands the only dr, so only dr, that is our for a lower half plane is physically acceptable by the retarded requirement. So the causality demands the only t of r lambda is only physically acceptable. This term is physically acceptable by the retarded requirement. So for r naught is equals to 0, so physically acceptable field potential, this acceptable potential in the Lorentz gauge. That is our a x lambda is equals to a naught lambda x lambda plus 4 pi by c df4 x dr r lambda g of x lambda, and this term got satisfied the equation as alpha 0 x lambda also so is equals to step function. With this step function, r naught upon 2 pi, that is 2 pi for r, 2 pi into this 4 pi by c. We here from the very first equation, from equation number 1, as we prove that the value of this, so this term give us delta of r lambda square, right? With this d4 x dash and j term, current density term x lambda, and where this lambda x lambda satisfy the equation as box operator, sorry, so box operator a alpha and this 0 of give us equal to 0, so 0, then we have this term only. So finally this a alpha x lambda is equals to step function r naught upon 2 pi. We cancel this 4 pi upper to 2 pi, then it will become 2 only, 2 by c 2 by c d4 x delta j delta of r square. So if you get confused with any step or with any equation, then you can leave a comment on the comment section. I will again explain in the comment section where what I have done in that equation. So this is our derivation of green function by using covariant approach, and proceed further. Then this is our taken equation after that proceeding. So